The principle of least privilege is part of the tenets of the zero trust architecture or zero trust mentality that we're bringing into software. And software is becoming more interconnected and more complex, and we have more players within that software. It's hard to say which ones can we trust and which not. So the default is not to trust, and the default is to minimize the amount of access someone has to the bare minimum that they actually need. Any more than that, what you are essentially doing is increasing the attack surface. More access that exists that isn't mandatory. In general, more access that exists, but indefinitely access that is not mandatory is more attack surface that a rival can manipulate to ruin your app or to steal data.
Hello and welcome to Dev Academy podcast, your gateway to the insights and wisdom of prominent experts and engineers from around the globe. I'm your host, Bartosz from Dev Academy, and it's my mission to help you glean insightful knowledge from the vast experiences of our distinguished guests. Each week we will delve into timeless topics in software development, focusing on crucial areas like security, quality, and design. Join us as we unravel the complexities of software engineering, offering you a practical, in-depth perspective. Let's embark on this enlightening journey together and transform the way we create and understand software. Okay, hi, please meet Bartosz and Or today
And
on the
or
show.
what?
And or what? Today our guest is or Weis or Weiss. How do we say it properly?
Yeah, you can go with both. The most correct one is Weiss, but
Weiss.
come from the German root. But Weiss is also acceptable.
So, or welcome to the show. And
My pleasure.
today I'm gonna talk with our guest about different access control models from the perspective of web applications. And before we jump into, or could you share just briefly for our audience, how did you start your journey in the tech industry, especially in the web security and software development?
Yeah, for sure. Um, so I started writing code at the age of 5, but my career actually took off serving in the intelligence corps in the IDF, where I was an officer, developer, team lead, yada yada yada, and there is where I got most of my both initial developer experience and cybersecurity experience. I then proceeded to work in a startup that built containers before container technology was a thing. So I learned a lot on networking and building secure silos for software early on. Then I was a VP of R&D in a cybersecurity company catering to governments, armies, and like-minded agencies worldwide, working only on defensive solutions, not offensive ones. Really proud of that, especially in retrospect. And between late 2016 and up till getting close to maybe soon it will be 4 years, I co-founded and ran a CEO a company called Rookout, which is a production debugging solution. So I actually brought a lot of my cybersecurity experience in hooking and memory manipulation and brought it from the cybersecurity space into the debugging space. And Rookout today is a part of Dynatrace, which is also a significant monitoring company. And during my time working on Rookout, I found myself rebuilding the access control solution to our product 5 times when the company wasn't even 3 years old. And it drove me insane, as you can see. And that's what brought me to create Permit.io with the premise of never building permissions again. So I focus a lot on access control and best practice for it in modern applications as part of my role as co-founder and CEO in Permit. And we're really trying to make it so developers can securely and easily focus on their software without having to build authorization. Just like you don't want to build authentication or yet another database or billing, we try and make it so that you won't have to break your teeth trying to build authorization yet again. And so that's my background and how also I got into focusing on authorization specifically. So a lot of experience in cybersecurity and also a lot of frustration specifically in building applications and building access control.
Yeah, that's usually how it starts, right? You have a problem, you have a pain, and you are trying to fix it, and that's how unicorns are born. Um,
Fingers
we
crossed.
will, fingers crossed for sure. I cross the fingers for Permit.io, and I see that it looks good from the, perspective of the problem that it tries to solve. And before we jump into those technical topics, I mean, if you could time travel today, would you
Yeah.
travel to the future or to the past? And how
Hmm.
far would it be and why?
So this is a very tricky question because it depends on the laws of the universe in regards to time travel in our scenario. So am I traveling, if I'm going back in time, am I going into a parallel universe or am I going back literally in this universe? How do you handle conflicts? How do you handle uh, situations where paradoxes where I don't know, kill myself or kill my great great grandfather or just cause him not to meet my other ancestors. So just on the safe side, so I don't destroy the entire universe and my entire existence and just fall into a recursive loop of failure, let's travel into the future. I think that's the safer choice. Also, something that happens naturally. And can probably work better with the laws of physics. And I think I'll travel to somewhere around 2045, 49, because that's where Ray Kurzweil and other futurists are predicting this that singularity would happen. So I don't have to travel too far into the future to get into a point where I can potentially upload myself to the cloud and persist potentially forever and get access to all of the future knowledge. So I think around that point is where maybe people would get a chance to leap on that train, and maybe afterwards that train would already have left. So that's my answer. I'll go forward into the future as close as possible into the singularity.
Oh man, this answer actually brings me back the ideas of simulation theory and Nick Bostrom. Do
Right.
you
Mm-hmm.
recognize this guy and his thesis that he
Mm-hmm.
makes about the future and the simulation?
Yeah. This is actually a very common theme in a podcast that I run called Command Shift Left. Somehow we always end up talking about the likelihood that we're running within a simulation. So you'll fit right in. We really should invite you for an episode there as well. And yeah, and I think like statistically, like the claim says that if simulations exist, then they're more likely to be more simulations than underlying actual realities. So if there are more simulations, statistically, you're more likely to be in a simulation than in the underlying one true reality. And I say, for one, yeah, that sounds about right. And B, what does it matter if running in a simulation route? For us, it's the same thing. But I'm all for recursively creating more and more simulations and more uploaded realities within the ones that we have. And I'm excited for the virtualized future for all of us.
I think that's a topic for a great story and episode to cover in deep those problems. But let's just today focus on something that I think our audience, or maybe not, maybe they want to hear about simulation theory, but we will find out. But for
Write
the
to us
sake
in
of
the
today,
comments. Let send us
yes.
an email. Reach out to us on Twitter and tell us if you want to hear more about the simulations.
Yes, but for the sake of today theme, I want to
Mm-hmm.
start let's create a grounding for our future discussion about different access control models. So I will start simple and then we will go deeper. So before we continue with our insightful conversation, I'd like to share something that I'm really proud of: the Web Security Dev Academy Bootcamp. I created this program to help developers like you deepen their knowledge in web security. If that sounds interesting, you can join our exclusive waiting list to be notified about the next launch and start receiving tailor-made security tips. This is not a usual online course, but group-based cohort training with my direct support. To join the waiting list, visit websecurity-academy.com. It's websecurity-academy.com, or check the links in the description. If bootcamp isn't quite what you are looking for at the moment, thanks for your support, and now back to our conversation. Just out of your head, just right away, if you think about the problem space, what are the common security threats today that developers should be aware of when building, especially web applications?
It's actually quite an easy answer because other people smarter than I've already answered. If you look at the OWASP top 10, you'll see literally the list that is defined there. And you will see that the A1 most significant risk to applications is access control. So it has the most incidents, it has the most bugs, and the greatest area of effect on the security and stability of the applications that we create. And it actually makes a lot of sense because the more complex our applications become and the more interconnected they become, what are you allowed to do within their context has more weight. You're able to impact more things and break more things within the manipulation of access. So there's more things within the app. So the more things you have access within the app is where more damage can happen.
I think that this grounds a perfect platform for our conversation. And going further, if we talk about access control, I think it would be really bad if we don't mention the principle of the least privilege and its importance in this access control. I mean, because I think, we have different frameworks, we have different.
For sure, for sure. And it's actually a very basic, very logical thing. So, to explain, the principle of least privilege is part of the tenets of the zero trust architecture or zero trust mentality that we're bringing into software. As software is becoming more interconnected and more complex, and we have more players within that software, it's hard to say which ones can we trust and which not. So the default is not to trust, and the default is to minimize the amount of access someone has to the bare minimum that they actually need. Any more than that, what you are essentially doing is increasing the attack surface. More access that exists that isn't mandatory. In general, more access that exists, but indefinitely access that is not mandatory is more attack surface that a rival can manipulate to ruin your app or to steal data or cause mayhem or damage in other way. And when you think about it, it's basically a direct derivative of one of the most fundamental concepts in security, which is the weakest link principle. When a rival tries to attack a system, they don't need to break the entire system for to cause their damage or to achieve their goals. They just need to find one loophole, one weak point that is significant enough that allows them to trump the rest of the system. So if one link fails, the entire chain fails. So if we say that the friction point that we have is within one link, potentially, the less links we have in the chain, the less attack surface we have. In other words, the less likely that rival is to be able to subvert our system.
Exactly. So this creates another problem because as soon as we are aware of these concepts, then we, if we turn into the software thing, then we, as engineers, as builders, as software developers, we have different models to tackle this problem. And
Mm-hmm.
traditionally, one may say that in web applications, I'm not saying about, because if we zoom out for long enough, we will end up with different models that are present in operating systems, things like access control list and something like that. But we don't want to go that deep right now when it comes to infrastructure or system wise or operating systems. I want to focus right now on applications. So
Mm-hmm.
the popular approach would be role-based access control, RBAC, right? This is
Mm-hmm.
something that seems to be well adopted, well understood. You know, because one person is a user, someone is a moderator, another one is an admin, and we can somehow abstract away to a particular role how we, on the code level, implement it, right? We end up doing some if and else's on the different facets or layers of the application. And
Mm-hmm.
how do you think, why is that we started from this role based in the beginning, and then we will jump into different approaches?
Yeah, so role based access control, RBAC, or also commonly known as RBAC, is the bread and butter of the access control world. I wouldn't say it's the best model. There isn't such a thing as the best model. I wouldn't even say that it's the where most applications are headed, but it's a point in building policies and building access control that almost every application would go through. Uh, to say the least, it's because it's the most well known. It's the most frequently used, and it's the one that, more importantly, maybe the customers are most familiar with. So they'll be requesting it. So this is why almost any application will go through a point where they'll need to implement role based access control. Um, Another reason why it's so common is because it's very natural for us as humans. We like to think in labels. We like to group things together. So being able to, instead of talking about the permissions directly, instead of having a list of permissions of what you are allowed to do, for example, which files and which features in the software you're allowed to create, read, update, delete, send, invite, etc. Instead of having just a full list of that, but boiling it down into a single layer label like editor or admin is very, very useful. And we can intuitively, as humans, we like to intuit um, from labels. So by saying, for example, you're a king or you're a bishop in the court, I automatically have a picture in mind of what you're allowed to do and what not. Within the title, so those are the classic titles that we had in organizations or in society, and those concepts we like to bring them also into computer science and into application access control. So organizational roles and application roles aren't the same thing, but they come from the same mindset. So this is why RBAC is very common, though it's still very hard to implement. Even today, where almost every application would want to have role-based access control, still a lot of players are struggling with it. And the reason is that unless you decouple your policy from your code, you'll end up constantly having different types of role based access control that you constantly re implement into your system. So, a best practice that I already want to kind of put on top of the table is decoupling policy and code. In modern applications, that essentially means having a separate microservice for authorization. So when the application changes, you don't need to change the authorization layer. And maybe more importantly, when your authorization layer changes, for example, you add another role or you add another permission, you don't need to change the application itself. And if you don't do that, if you just assume I'll just bundle it into it's just a few more if conditions in my code, that's usually a recipe for having a bad time at like 2 months down the road.
Yes, definitely. I think that the approach with the separate microservice is on the spectrum, because I don't think there is like a 0-1 dichotomy on how you should or should not do this. It's the
Mm-hmm.
question of how far you abstract away, right? I mean, at least you, if you start from the idea of abstracting away from your business logic, let it be, I mean, assume you are still in a monolith, right? You don't have a microservice, but the worst thing you can do probably is to bundle your logic and your business rules with the permissions inside of the code, because
Mm-hmm.
you don't really need, actually, I mean, assuming that we are in the monolith application, to have a microservice. We can go down this road later on, but in general, I think the idea is to just abstract away, just decouple things. I mean, if you are implementing a business rule, do not if else the stuff when it comes to permissions inside of this application domain, right? If you are at least having a packages or
Mm-hmm.
some components that abstract this away, I think it's a good start. And of course, as long as you are on a single, let's say, application. But if we are go further, if we go further, and then you have microservices and something like more distributed systems. I mean, having a distributed approach like dedicated microservice can still be a thing, because you solve different problems. As you mentioned, you don't have to upload and change the business logic if you properly abstract away. So I would point it that abstraction is the key, and depending on the system, you decide on how far you go with this abstraction. Do you
For
agree?
sure. Yeah, for sure. In general, as a good developer, one of the main things you need to know is don't build too much that you don't need. Like in both in software development and cybersecurity, you should assume that you don't know anything about the future and what the actual problem is. Things are going to change. Requirements are going to change, and if you build too much in advance, you'll probably be building the wrong things. So try to keep it minimal, and this also actually aligns with what we talked about before in security. Don't build too much area. Don't create too much attack surface. Even the security layer itself can become part of the attack surface. So you want to keep things to the bare minimum that we actually need, but we at the same time you also want to recognize that it's going to change. Policy, access control, the features and logic that we have in our application, how our users behave, this is something that is alive. It's constantly changing with the evolution of the software itself and with the evolution of our audience. So we should have the assumption that it's going to change, and if that assumption exists, we should ask ourselves, how are we going to react to that change with the most ease and with the least amount of friction? And that means that we decouple it out. So think about it this way. Even if you have a microservice for authorization that always returns true, that's your policy. It just returns true every time. You're still better positioned to change it in a separate way from your application than if you have that same if condition that returns true baked into your code. So you don't have to build a lot. You can have it very simple. You just need to build it slightly separately, so you'll have an easier time upgrading this, changing this, adding the more logic down the road. So even if it's just a separate function, or if it's a separate microservice, but it's a separate thing that you can upgrade, you'll be good to go, and you'll gradually add the things that you need. You'll use a policy engine, you'll implement different policy models, etc., etc.
Yeah, I really like what you said, that as soon as it's separated, let it be, let's say, a function, it's still something that you think upfront. It may be already a microservice that just returns true, but I think we're talking about the same problem in different dimensions. One dimension
Hmm.
is general abstraction and decomposition, and the other way is actually how far you go with that, because it strictly is derived by the current architecture of your system that is also going to evolve, of course.
Right.
So before we talk about different access control models, do you think the solution for the inherent problems of role-based access control could be, it's an open question, I don't expect yes or no, but if we expanded to hierarchical role-based access control, does it actually solve the problem or just makes more issues? If you think about the roles are, inherited and make some, different taxonomies.
So first of all, to kind of set the stage, so hierarchical role-based access control is usually called RBAC, relationship-based access control, REBAC. And it's very popular today, and it's also being become popular through projects like Google Zanzibar, which is how Google implements access control for solutions like Google Drive and YouTube. But it's not a silver bullet. In the end of the day, all of the policy models that exist and all of the frameworks that exist are just tools that help us think about the problem. And real applications usually end up mixing models and mixing different capabilities and different implementations. Because as we said, they're a live thing. So as they live, mutate, and grow, they'll reach into different areas that are not necessarily adhering to your classic academic like model for policies. So yes, I'd say RBAC and or in general hierarchies of roles is a great way to improve the granularity of your policy, but expecting it to be a silver bullet that will solve everything, you'll probably end up being disappointed.
I love that you talk about this in I think in the similar manner that I'm trying to solve problems. I call it a models or conceptions or mental models that before
Mm-hmm.
you actually, get your hands on the keyboard and code. If you cannot imagine the model inside your head, if you cannot draw it, I mean, I don't think it makes sense to start coding it from the scratch out because you will end up doing some piece of mess. But what I have a feeling that what we are talking about is kind of like conceptualizing or making models or mental models, how we actually model the reality. And then once we understand the reality and have some kind of understanding, then we can think of the structured implementation phase, right? So this is something
Mm-hmm.
that I think it's important to bring on the table. As software engineers are not about, taking the keyboard and writing code because it's not what we are supposed to do. We are supposed to model the reality, and now we are talking about the strict piece of this reality, strict angle, which is the authorization and authentication, right? So we
Mm-hmm.
have covered role based, relationship based, and now there is some another approach which I think you would like to talk more about, which I would say is ABAC,
Right.
attribute-based access control. So another jump in from my side is that you pointed important problem is the granularity. How we actually achieve the appropriate level of granularity, right? Because
Correct.
maybe when we start, admin, user, and moderator, like a starting theme can be great, but then as the application gets into complexity, oh, in this particular case admin should not do this, or in this particular case the moderator should behave as admin. And then we start to get into the exceptions and exceptions on exceptions, and things actually start to deteriorate.
Yeah, for sure. So let's maybe set the stage quickly. So RBAC, so starting with the most basic one they described. So RBAC could be RBAC with multi-tenant, and you can have multiple roles for at multiple tenants. This is the idea of assigning permissions to users through static labels or reverse static labels called roles. Then we have relationship based. So we'll have permissions assigned to users according to relationships that they have to various objects in the system. So you can describe or you can imagine a graph of edges of nodes. So what some of these would be users, some of these would be resources, and if you can traverse a path that leads from one object to the other, from an identity to a resource and to a specific permission, you can say that they're connected and you have access. And RBAC is great for organizational hierarchies, for so groups, essentially identity groups, and for resource hierarchies. So think like files and folders. So you get access to a file because you have access to the folder. Sorry, that file is within a folder, and within a folder, within a folder, within a folder, and you have access to that top folder, and through it you derive access to the underlying file. So RBAC is great for that and for having specific access to specific resource instances. So, for example, describing ownership, also something that is classic to do with RBAC. ABAC, first of all, I say with ABAC you can potentially describe everything because ABAC is the idea of describing policy as a set of conditions on attributes. So an attribute can be anything. So for example, we can have the attribute of what things do I own. So I'll have a attribute that is a list of folder IDs that I have access to. And so you can already start to imagine how we implement RBAC on top of ABAC. So ABAC is kind of the most advanced one. But it's not the best one to think about all of these problems. So a lot of times using roles or using relationships, it will be easier for us to both think about the problem and model it. But there are cases where thinking in conditions on attributes is the most efficient. And that is when things are highly dynamic. So constantly changing a graph for things that are changing is something that is doable, but it's inefficient and also kind of cumbersome to think about. But thinking about a condition and an attribute would be very natural. So let's think about examples for things that are dynamic. So for example, time. So time-based access. You can only access this file during the afternoon. So one attribute would be the current time, and the other attribute would be what period of time you can access the file. So we'll be checking that the current time is equal or is after the attribute set on the file. Another example would be, for example, geolocation. People move around. So you can say only people in Spain are allowed to access this file. So I'm currently in Spain, but I'm in a car, and in a minute I'm going to be in Portugal, and so I should stop accessing that file when that happens. Or Another common example is usage. So quotas or history of interaction with the software. You should be able to read this article only if you haven't read two other articles this month. So things that change dynamically are usually the classic thing that you'll do with ABAC. Now, these models are different and separate, but as I said before, you'll find almost in any complex enough application a combination of all of them. So, but it's still helpful to think in these models and to think how you layer them on top of one another. So for example, imagine thinking about having a attribute based access control condition on top of a relationship. So we describe it and we say you have access to this file, you're connected to it as part of the graph. But before we just assume you have access to it, we'll also check for the time access. So you'll need both the ABAC policy and the RBAC policy to work together to implement accessing a specific file within a window of time.
So from what you said, I'm trying to build a picture of these different approaches. If we talk about this relationship based kind of like
Mm-hmm.
hierarchical role-based access control, we can think of, for example, Google Drive, right? So
Mm-hmm.
there is a hierarchy of things, and then we can model the problem that, okay, there is a, assuming that I give you the access to the folder, I should give you access to all the files and folders inside that folder. So it's propagating. So it's easy to somehow model it with these approaches. But on the other hand, this is not always the same case. Like I like this example with you should be only able to read this article if you read not more than 3 already. This is
Mm-hmm.
sometimes visible over the internet, like you have 3 or let's give a number of articles to read for free, and this is based on attribute, right? You have an attribute or a number of read articles, 1, 2, 3, and this actually does not uh, mean that your role changes, but some condition over time changes, right? uh,
Mm-hmm.
do you have any more examples, or where we
I,
can put this
I,
attribute
I,
model?
I have a ton of them. So also think of something um, quotas for using an API. So you're doing throttling. So you're allowed to do 1,000 calls within a minute, let's say. So that's also a classic scenario. And another one that I described before is geolocation. So think about implementing GDPR. So users that are in Europe should only work with the European servers, and they shouldn't be able to access the US servers because that would be violating GDPR because their data isn't supposed to be stored in the US. So even if they by mistake get to the American server, we want to make sure that they don't access it. So they might have the access to the logical object or access to the app, but we want to make sure that the specific resources are limited to the ones in Europe. So there are a lot of scenarios like that. There, I can also give you scenarios that mix the two. So think about Um, a very common pattern is having a managed account. So think about a healthcare app or your account in Spotify or in your telecom company. So if a person that owns the account and there are family members that join that account. And now common scenarios is okay, so with RBAC we'll say who belongs to this account, and we'll give them different roles in hierarchy. So also there might be hierarchies of objects. So you'll have the account, and then you'll have user profiles under the account, and you'll have the billing plan under the account, and you'll be able to derive access to it through the RBAC relationship. But then you also want to implement all conditions on top. So, for example, you should be able to access your plan only if you're on a pre-approved device, on a pre-approved phone, or only if you're within the right country, or if you haven't been explicitly blocked. So sometimes you'll have the ability. I'm managing the account and I want to block specific features for specific people. I don't necessarily want to change their role, but I want to block specific features within the plan. So you can already see both RBAC, RBAC, and ABAC mix into these, and these are very common examples. They exist in a majority of apps. But it's also important to note that each application is a snowflake. So I can keep describing common scenarios that I see our customers build, but I always end up having a conversation with a customer where they describe some wacky thing that is unique only to them because of their the way their company works with another company or something like that. So um, it's great to think in use cases and it's great to think in models as we covered. But I'd still recommend for any developer building this and any security professional trying to secure this, don't assume that you'll have just these models or just these use cases. You always need to prepare for things changing because that's usually how it ends up being.
I love when you said that the customers usually say our business is unique, our company is unique, our use case is unique, our product is unique. I mean, this is so common along the years of the industry experience when you build custom bespoke software. You know, you can actually put this label to almost, at least from my experience, say that this is we are just we are the only one who are specific, and this is a very specific case. We can I completely agree with you that on some level we will talk about some similarities in models, but when you
Mm-hmm.
talk about a specific product or service or company or product, there will always be true to say, I mean, we are very specific. We have very specific use cases. So probably, maybe it will be exaggeration, but for the 90% of the cases, models and those control access control models or any other models can fit. But this 10%, you will have to break your head around, and this is not actually fitting the picture. I need to find a custom solution. So frameworks in general, if you derive it from the general to the general problem space, they solve 90% of the problems. But the real thing, as the engineers, we need to dive into this 10%, because every if at the given
Mm-hmm.
scale, a project or company will, oh no, this is a very specific case, this is the unique way we do the business, this is the unique way our product works, and so on. So it's nice to hear a similar vibe from other developers. So jumping to the next
Sure.
question, do you
Mm-hmm.
think that microservice and cloud native applications, um, do they differ in case of this access model controls, in case of ABAC or AirBAC and so on? I mean, if we talk about microservices, does it actually ring a bell in case of, okay, we
Should I pick
default
one
to,
model or another if I'm
yes,
doing
does
model
it
authority?
sound like a default to another one? Because maybe on the classic web apps, okay, we default to Reebok, but maybe in microservices we default to something else, or it doesn't matter.
So I'd say the baseline answer would be that it doesn't matter. You can have complex policies regardless of how they're structured. That being said, usually, naturally, if you have a microservices application, it will gravitate towards being more granular. And I'll explain. The moment you have a component that is split off, it will evolve more quickly. This is why we wanted to split off the authorization layer so we can evolve it more quickly. And when we do this with software in general, we'll have that component by be changed by other developers more quickly. Something that changes more quickly means that it would grow to have more features and more capabilities and more complexity. The more complexity you have, the more granularity you need in the policy to be able to describe it correctly. And obviously, there's a tension here between how fast you want to go, how big area you want to cover, and how well you want to tighten the screws around it with the policy that you have. And so I'll go back to kind of the between the lines here and say there isn't really a reason that to say that monolith is better than microservices in this aspect. But there are some characteristics in the choices that you make that will might make certain policies work better. Another one is the frameworks. If you work in monolithic applications, you'd usually have one language. And so, for example, if you're working with Python, you might work with a framework like Django. So Django will have Django admin built into it, and you'll have one place where you can manage roles at least in a kind of a very nice way. But in microservices, you'll often be polyglot. You'll have multiple languages or at least multiple frameworks, and you won't be able to use that single framework's access control. So you'll need access control that is more fine grained, that is more dynamic. And that usually comes with more advanced policies as well.
So this is a great point to mention that when you talk about microservices, you usually end up with different languages or often, and then there is no single point that gives you out of the box. So this brings me to another question. I would say
Mm-hmm.
that a lot of frameworks already have out of the box those role-based access control. Can you recall any frameworks? I'm not talking about tools that brings this functionalities, but I'm talking about conversely, if I know that there are a lot of frameworks that provide me role-based access control out of the box, can you recall any frameworks that give you attribute based access control out of the box on the other side?
So there aren't a lot of frameworks because a lot of these things, so in the monolith space we said it's usually less complex and then you stick with more simple policies. I've seen things that you can build on top of 𝐭𝐻 that can kind of work, but in general doesn't really scale well. It's a very good solution, but it's limited in how much you can scale it out. um, and I think primarily, if you want to see attribute based access control solutions, you'd find yourself kind of automatically or naturally gravitating towards policy engines. So things like OPA, Open Policy Agent, and Cedar from AWS, another open source policy engine. Or there's an older, I think less cool tool. There's Casbin. There are a lot of open source policy engines that you'll end up implementing policy as code to implement ABAC and more fine grained policies. So this is where you usually find yourself if you're kind of aiming for ABAC both in monolith and in microservices.
You mentioned a couple of terms. Did I hear opal properly?
So I mentioned OPA, Open Policy
OPA.
Agent. Yes, and it's a popular CNCF project. But Opal is also a very important project in the space, though I'm kind of biased because I'm one of the authors. Opal, Open Policy Administration Layer, is a solution to manage policy engines at scale. So let's say you've decided that you want to work with OPA or you want to work with Cedar. So now you have multiple engines like these, and you need to load into them the policy and data that they need to actually make authorization decisions. If you have just the one, or if you have very simple policies, your life is easy. But when you have multiples of these and at scale, you need something to manage this. And this is what Opal does. It allows each policy engine to subscribe via a pub sub channel to the policy and data that it needs and have it receive them on the fly. We built this inspired by how Netflix worked with OPA. So Netflix adopted OPA, and there's a great YouTube video as part of the CNCF collection of talks on how they work with OPA, replicating the data that they need with a service into OPA. And since they didn't open source it, my co-founder Asaf and I took it upon ourselves to recreate it and open source it, and that's OPAL, Open Policy Administration Layer.
So it feels like this universe of attribute-based access control is a little bit more complex. We have to think about rules engines, policy engines, and it's not that you just take, as you mentioned, admin panel or admin thingy from
Yeah,
Python
just
framework. You have to just be more fine-tuning those rules and policy engines in order to adapt to this dynamic space of policies.
Yeah, just think about adding more rules. Up till now, you defined access only according to country, but now you also want to do it by city, or by sub-region, or by time in addition. As we said, this is alive. The moment you started to do this filtering, it's a matter of time until the product manager or the customer would run into the room and say, "Oh, we're already filtering by country. Can we also do cities? It's really critical for this project." And then you'll need to develop it, and you don't want to rebuild the entire app just to add that thing. So being able to update policies dynamically is really a key advantage here that you get from policy engines. And the other aspect is how you manage the data for this. So we're talking about attribute-based access control. These attributes, this data, how does it arrive into the system? So for example, the list of users that we have, or the list of cities that we allow, or the quota that we have for each of our users. If we say you're only allowed to read 3 articles, how does the system know how many articles you've read? How do we update this in the relevant frame of time so people don't end up reading 10 articles by the time you update the system? And how do you do this without disrupting the app and without creating dependencies? So think about, if the lazy thing to do, and something that a lot of people end up doing without thinking about it, it's kind of a common pitfall. So the easy thing to do is, as part of the authorization query, as part of the authorization logic, I'll go and I'll ask the database, what is the amount of articles that you've read? On the surface, that sounds like a great idea. In fact, it's a horrible idea, because now your application's livelihood, your application's ability to run is coupled to that database. Because think about it, unlike authentication, so authentication verifying who you are, allowing you to log in, that happens once per session. Authorization happens multiple times per request that you send in. So if authentication is down, new users can log in, but the ones that are logged in can continue to work. If authorization is down, everything is down. Nothing works. And now let's say you have this database, and suddenly it's slow because it's bombarded by another service, or suddenly it's unavailable because there's a hiccup in the network. Your entire application is down just because it's unable to ask it what is the number of articles that you've read.
Mm-hmm.
So you need a different solution to that. So you need a way to asynchronously in the background load the data that you need and manage it for the policy engines. And this is what Opal does. That's the replicator pattern. So instead of constantly, as part of the authorization query, as part of the critical path, going and fetching more data, we load the data in the background and we continuously update it until we have consistency. Um, so there's a lot more to unpack here, but what I'm trying to kind of highlight is that there are sensitivities that come with more fine-grained policies, and you need the right tools and the right understanding to be able to approach them without shooting yourself in the foot.
This brings me to a question about consistency, because you mentioned that you are updating something in the background so that you don't have to authorize every single request. Does it, or if does, it cost, how do you tackle the problem of consistency, right? Because when you talk about databases and we talk about, those hiccups and things like the performance, sometimes some systems can actually accept eventual consistency, right? So does it actually fit in the picture that, okay, we are updating, but because of this background jobs, we assume so-called eventual consistency, right? So it doesn't mean that we always are consistent because we propagate changes, but for our case, it's fine to be eventually consistent. Does it actually fit into the problem space as well in those
For
engines?
sure. It's a question that you need to ask yourself. What is the level of like you ask yourself what is the level of granularity that you need for your policy? You also need to ask for the data for the policy, how consistent you need it to be. And so there are different solutions that will give you different levels of consistency. So there's highly consistent solutions like Google Zanzibar and implementations like them that use something called zoo keys, which basically cryptographic signed cookies on slices of data to know um, that without a doubt that you have the consistent segment of data. And there's another approach, the one we take with Opal, which is eventual consistency, but focusing on having it uh, update very quickly. So with Opal, what we do is instead of sending the data, we send instructions to get the data. So the first thing that the policy engine knows is that it has that it's inconsistent, that it doesn't have all the data that it needs. So in that intermediate state, it can already make different decisions based on, for example, delaying or returning a default answer, for example, no. So that's one thing. So you have the ability to react to the intermediate inconsistent state. And the other one is have this thing be very, very granular in how it does the data updates. So instead of sending the entire list of quotas, just send the event, the instruction to get the data for just the update that happened for the quotas. So the bits of data that fly around are very small and update and become consistent again very quickly. So this is the other approach. So you can be eventually consistent, but get to that eventuality very quickly. And you can figure out what is the mean time to consistency that will exist within the system working like that. So you can say, oh, these are usually I'll be consistent within 100 milliseconds. Is that enough for what I need for this policy? If yes, then you're good. This is the right way to approach. If not, okay, maybe either speed this up or use a solution that is that has higher consistency. And as engineers, these are dilemmas that we need to approach as when we're building these things. But we can reduce the amount of friction that we have on understanding this and building this correctly by adopting tools like Google Zanzibar or OpenFGA or Opal and OPA. So when you think about these problems, you have off-the-shelf solutions to address them.
Okay, so if we stick to an example to make it more concrete, if I imagine that I have a Google Analytics account and I have admin access and I have different pages. So let's complicate stuff a little bit. I have Google Analytics, or maybe other way around. It would be better. I have a Facebook account and I run multiple ventures, and then I have multiple people helping me out with the ads, and I'm giving them different permissions for different sub accounts on the different levels. So this is an interesting case, I would say, because it actually will bring on the table those problems that you just described. And I have a shop A, shop B, and shop see, I'm the like a top on the top. I own those shops, and I hire two different companies. One company is working with the shop A just to set ads, and another company is just auditing the one on the A shop, but also
Mm-hmm.
auditing the B shop. And there's a third company who can work around everything around from the top and just kick another out. My question is, uh, the problem that we talk about the consistency. How would this be complex landscape be solved, or what do you think as the first thought? This can be solved with this opal thing or maybe Zanzibar thing, because this is, I just blew the random problem that is fairly complex to my understanding, and
Mm-hmm.
have a lot of to do with different entities, different permissions, different attributes, different angles. And and let's put it into the microservices world, and we're completely complex. And do you have any idea how to tackle this problem in case of this choosing the right rule engine or policy engine or framework like OPA or Zanzibar? How would you look at this particular problem that I just made up?
I'd usually I'd usually ask you more questions to get into uh, more things around how you expect the data to work and how you expect your organization to work with the tool that you build, or how you expect your end customers to work with what you're building. But to without getting into a very long session, I'd say something like this: for most scenarios, including the one you described, eventual consistency is usually enough. So let's picking in your scenario. I think the most sensitive thing there is the spending of budget. Like
Exactly. I want to
when you
make
can.
a decision. I'm cutting off the money, just kick everyone else because they are just drowning my money. They are just spending something on something else. I just immediately want them to be kicked out of my accounts. And maybe eventual consistency is enough or not. I don't know.
So it depends on how the system works. So if you can say within 50 milliseconds, within 100 milliseconds, having everyone be locked out, that's enough. Then yeah, you can work with that. And for most scenarios, that would be okay. If you're saying no, the I'm doing high volume trading here. I'm working with algo trading, and this is really fast, and I don't want to take any chances. Then yeah, go for the highly consistent. Have that huge system with the locks where when you when you connect to the system, it's centralized and it tells you uh, automatically if you have access or not, even without consistency having to propagate. And it's a question, it's an engineering question like any other. What is the how do the business requirements that you have translate into the physics of interacting with the system? In most cases, you don't need that full eventual. You can work with eventual consistency, but it kind of depends. Another factor that comes in here is how large is your data set. So the bigger your data set is, the harder it is to make it eventually consistent, or maintaining that eventual consistency within a specific policy decision point or specific policy engine, without breaking it down into more shards of that data. Um, so in general, I'd say if you have less than 1 million users, you probably don't need something like Google Zanzibar. But if you do, and you have high volumes of data and you need to keep them consistent, then it's a good way to do this. This is why Google built this, because they have multiples of millions of users that they need to keep consistent. By the way, there are other pros and cons that come with that decision. So the Google Zanzibar like system is really great for RBAC, really great for relationships. It's not that good for attribute based access control. You can do some attribute based access control, but it's a lot harder to do, and you're limited in the complexity that you have there, in limited in how easy it is to integrate more data into the system. So there are pros and cons as with everything. Um, and the best I can, without diving more into into the imaginary scenario, I can give you kind of rough guidelines. So if you don't have millions upon millions of users, or another reason where you have a lot of data, you can probably work with the eventual consistency. And unless you have really high frequent changes where you can't allow um, 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 some period of time for consistency to propagate, then go with the again with the highly consistent system. Otherwise, yeah, I'd go with the more lightweight eventual consistent system.
I really like the way you look at the problem that, as usual, it depends. But the real strength is actually to be able to say it depends on what. And of course, it depends. But you should be able to list those factors upon which the things depend. So you mentioned a lot of them. I mean, how big is your database? How much of a delay you can accept? How much of a latency you can accept? How frequent changes happen? How many users do you have? How much data do you have? How frequent do it change? I mean, are you able to
Mm-hmm.
accept 100 milliseconds or not? Maybe you don't accept any latency. So I think that the important thing is to mention that it depends, but you really need to be able to list those factors upon which you make a decision that, we always, as engineers, says it depends. So a great answer. And I would like
Thank
to
you.
close this with an interesting question, I would say, or maybe two
Okay.
last questions.
Okay.
Or maybe other one. How do you foresee the evolution of access control models? Like we mentioned, we stick to those we already discussed, but do you think that ABAC or RBAC, are going to change in the face of emerging technologies? Do you foresee any evolution, or we're at the end of the maturity of those access control models?
Yeah, for sure. So I'll start by saying that before the models for access control are going to change, access control itself is going to change. So I think it's pretty easy to see. It's pretty apparent. 2 years from now, um, the way we use applications is probably going to be very different. If today most users in applications are human users, 2 years from now, it's probably going to be automated agents acting on behalf of probably other automated agents, on behalf of other automated agents. Somewhere down the line, hopefully there's a human if they haven't killed us yet. Um, but definitely you'll see a more significant percentage of non-deterministic AI agents acting in our applications, both as users and both as integrations between the different applications. So both the speed in which change happens in applications would increase, the level of features. So because these elements are also part of the software, you'll be able to do more things within each. You'll have more features automatically in every application, more area that you need to cover with access control, and you'll have more data. More data will be generated more quickly, and more data will be utilized in these applications more quickly. So it's basically it's the singularity. Everything is expanding out in ever increasing, exponentially growing pace. So yes, applications are changing dramatically. It's easy to see, and access control will automatically change with it because otherwise, things would just stop working because everything would be broken and hacked.
Let's
So
just hope that we will survive until 2049, as you mentioned at
yeah,
the beginning, that someone predicted a big implosion. So let's just stay alive until 2049 to see if this actually makes itself to reality.
I literally think that n- nailing down good access control is one of the most critical things for us to be able to reach the singularity without it destroying us. Just think about, what are you allowing this AI to do? Are you allowing it to run for president? Are you allowing it to fake actions for you? Anyways, I don't want to go too much on a tangent here. Um, but yes, so access control is definitely going to change, and as a result, yes, policy models are definitely going to change. They're already, as I mentioned, they're already better as thought models and tools than actual implementations. And my aspiration is that in 5 years from now, no one is going to say RBAC, ABAC, or REBAC. Those will become meaningless because you'll be moving into um, models that combine all of them in advance and allow you to talk about them in more simplified terms and allowing you to connect them to the more advanced systems and the way more modern software will be acting at that time. So we'll be thinking like AI about how we use applications. So an AI agent is not deterministic. It's not like your API code that does specific functions that you've programmed specifically into it. And it's not specific features that you thought of and designed and curtailed for each of your users. It's a much wider vague area. And so the models are going to be merged together and we'll be thinking in more higher level concepts. So I think groups, I think patterns of usage, I think levels of usage and throttling and pace, those will become the more common terms that we'll be using. And more importantly, we'll have better interfaces. Something that we really focus on in Permit is not just the building blocks, it's the interfaces that you provide for yourself, your developers, your product managers, your security team. What are the tools that you use to author policies, maintain them, audit them, etc.? And and here we can already see how this is happening in the bigger companies. So, for example, in Facebook, post Cambridge Analytica, um, they don't allow anyone to constantly access data by the company. But on the other hand, you can't block access to data because they need it for their work. So you need an intermediate option. That intermediate option is something that they ended up calling interstitials. So as you're interacting with their data, as your code is interacting with your data as a developer there, and I know this because my co-founder worked at Facebook on these tools, amongst other things. So as your code is interacting with the data, there's another AI as part of the access control system that says, "Oh, you're doing some patterns here that are anomalous. You're doing some patterns here that are at higher pace than usual. You're accessing data that has higher risk scores or is more complex." So this is already hinting at the new policy models. And what it does, instead of blocking you, it surfaces interactions, organizational interactions. So it would go and ask that AI would go and ask your team lead, is it okay that this person is doing this? It will go and check other systems about the risk factor of the data that you're using. It will ask you to provide more data personally. It will throttle you or try to suggest that you'll use other bits of data. So there's more interfaces here that will enable us to both keep our systems high pace and complex while still simplifying it for us on how we allow them to work and how we communicate what is okay or not okay to happen.
It sounds like it will become more and more complex to engineer and think about it, because if you talk about pattern detection, anomaly detection, some level of AI interconnected and multiple components, I think it's a topic for yet another podcast episode. But to close up with this current well-known access control models that we covered, how do you think developers, those who actually build those systems, can stay up to date with this different security standards to ensure that their practices over authorization, are up to date and comply with today's particular knowledge? Of course, we have education path, but just your view on that, as a developer to the developer, what can I do today to stay up to date tomorrow, so that those things change and I don't want to wake up one day that, oh, I am far behind what should be done today.
That's a great question, and they actually connect the point that you ended the previous section with, and this one. So, my hope is in the future you won't try to build all of these complex things. You'll have ready tools that you use, and I actually said this is also the answer for today. There's always a tension of build versus buy, but I think that authorization, just like authentication, just like billing, just like yet another database, is not something that is unique to any application. And building it is probably not the best utilization of your developer time. You can try and chase this wagon and try to keep up to date with it, but I'm not sure that you should. Maybe there are better things you can focus on that are in the core of the product and software that you're building. That being said, if you do want to chase this dragon, I recommend utilizing open source tools and connecting to their communities. We have a significant community around Opal. There's a significant community around OPA. There's a good community around Cedar. And these are great sources to be at the cutting edge of where these things are evolving, where policy engines are going, where things like partial evaluation, more advanced techniques of combining policy into databases and into other layers of the software. This is where these features are being developed today as we speak. So you can go in and connect to those both in those Slack, Discord communities, and also on GitHub, and kind of staying up to date and working with the open source projects themselves. If you don't want to buy a product, that's okay, but at least utilize some of the existing open source tools that come with the best practices. And in addition, I think I can also maybe on a personal level, what I enjoy most in my role is talking to other developers and other security practitioners. And you can literally you go on the Permit IO site. There's a link to a Calendly calendar, and you can just pick time to talk with me. Anyone can do this, and I encourage everyone to do this. And even if you don't buy our product, I'm always happy to talk to fellow engineers, help them think about their problem, help them think about the technology as it's evolving, and maybe help you stay up to date with the challenges here. And and lastly, I'd say maybe is kind of connecting to the point that we have in the beginning. If you do decide that you want to attack this thing, try to keep it focused. Don't try to build all of it at day one. Uh, have Learn about the best practices, build the most minimal thing that you have, and allow yourself the room to change and update it later. Even if you don't know the answers now, and you probably don't, because no one knows all the answers. You at least have the ability to change it without having to continuously and completely go back to square one.
That's a perfect summary of our discussion. Thank you very much all for this time, and I hope to see you around either or this show or on your show. See you around.
So, thank you very much. Thanks for having me, and sounds like a plan. Bye, everyone.